Hi, this is Joey Smith. Today we're going to learn how to run a regression in SAS. We're going to do two pretty simple different regressions. One of them is going to be a bivariate regression and one's going to be a relatively simple multivariate regression. And you're going to see that it's really easy to expand beyond just one variable in SAS. One of the things that we did in an earlier video is we imported data that was relating sales of jewelry, and inside that data set we also had the date and disposable personal income. And so we're going to start off by running a regression that tries to predict the sales of jewelry based on disposable personal income. The idea there is that disposable personal income should have a positive impact on sales. Jewelry is considered a normal good. A normal good is one that we buy more of as our income rises. And so the expectation is that sales should be positively impacted by by disposable personal income increases. The first thing that we need to do here after the import routine is we need to reset the data. And so I'm going to start off by typing in data 01. This is a brand new data set, and I'm going to put into that data set jewelry sales. And so I'm setting the data set jewelry S that's already imported from this import routine that we worked on earlier. Now from here we can actually go ahead and run our regression, because the jewelry sales data, we already have sales and DPI in here, and that's all we need to run the regression. And so we can just say procreg semicolon, and we need a model statement. And our model statement is that sales is a function of DPI. And then run. And if we run this regression, we can see that for our parameter estimate we get that jewelry sales has a positive impact. This is the coefficient for jewelry sales. The coefficient for disposable personal income. As disposable personal income goes up, jewelry sales goes up as well. And we have a p-value that indicates that it's significant at greater than the 1% level. In fact, it's significant at the 0.0002% level. So greater than 99% confidence in this estimate. One of the things to point out though is that our R-square is only about 9%. So we're only explaining about 9% of the variation in jewelry sales with movements in our DPI. And so we're not explaining very much. So we do get what we expect, that disposable personal income increases jewelry sales, so it is a normal good. But we're not explaining a lot of that variation. And so one of the things we might want to do is add an additional right-hand side variable. We need to go back up here into the data statement, just after the data statement, and we need to create a dummy variable for December. And so the first thing I'm going to do is show you how to use one of the date functions in SAS. Note that we have the date in the data set, and again, when we imported it, that date came right along with it. So we see the date here, and what we want to do is find out which month each one of these values in the date falls on. And so January should be the first month, February should be the second. And so what I'm going to do is I'm going to use this little function that says sale month. And so I'm creating a brand new variable equals the month associated with that date variable. Let's close the data set so that we can run this part of it. I'm just going to put a run statement here for just a little bit so that we can run just this piece and look at the data set. And so in data 01 we now have the sale month in there. It starts over every time you get to 12, because once you get to the December month. It starts again with January and goes all the way through December again. So we have an indicator for which month it is, and now we just need a conditional statement that says if sale month equals 12, then December equals 1. And so this creates a new variable called December, and it puts into December the value of 1 when the sale month equals 12. But we're not finished yet. We also have to say else December equals 0. We have to include this piece because otherwise we're going to have a bunch of missing values out there when the sale month is not 12. And so for every other month, December is going to be set to 0. And so it turns out it's in February. The sale month is February. That would be a 2. December would not be equal to 1. It would be missing. That else statement is important because it adds the 0 in there when it's not December. Okay, and so now we can run a new regression where we look at disposable personal income and December. Okay, so December is our dummy variable, and disposable personal income is a continuous variable on that income value. So we rerun that, and we look at the results, and we find that the equation for the regression is now that sales is equal to a minus 123.67872 plus 0.25489 times disposable personal income plus 3694.21716 times that December dummy. And look, before we had about 9% of the variation in our left-hand side variable, our dependent variable, explained by disposable personal income all by itself. But once we add in that December dummy that gives us an indicator for holiday sales, the amount of variation that we explained jumps up to between 92 and 93%. And so we're explaining most of the variation in the data with just in the left-hand side variable with just two right-hand side variables. Now, an important thing to look at, though, is to check to see if you've got any kind of strange anomalies in the data, and one place to look for that is in the residual plot. The residual plot, if we see some sort of pattern in the data, like a conical shape of these residuals, or a shape that goes above and then below, or from below and above, this indicates different patterns in the errors that can cause a problem with our estimates. Luckily, we don't see any of that in this plot. It looks like most of the residuals are centered right around 0, and that at a maximum it's somewhere around 1,000 on the positive side and about a minus 1,000 on the negative side. And so they're relatively symmetric. They're not they don't show any kind of strange shapes that might lead us to believe that the data has a problem. And so, looking back at the regression, to recap, we imported the data, we reset the data, and put into the new data set, data 01, the old data set, jewelry S. We created a sale month variable that we then used to create a dummy variable for December, and then we ran the regression that contains two right-hand side variables, disposable personal income and December, the dummy variable. And to emphasize, the bivariate regression that only had disposable personal income in it did not explain very much of the movements in sales, even though it was significant. Once we included December in the data, a lot more of the variation was explained. And when we look at the t-values, or the t-stats, and the p-values in the regression, we see that both disposable personal income and the December dummy are highly significant. Large t-stats very small p-values. Both of those indicate pretty much the same thing. And that's how you run a regression in SAS. Thanks for listening.